Welcome back. Welcome back to the course Privacy and Security in Online Social Media. We are in week 10, part 3. This is the last part of the week 10. So as we built in the first part, we saw some studies which were done on Facebook, OkCupid to collect data from users, and how those data can be, so to say, de-identified for the users, or users did not know that they were part of the study. All that content we saw in the part 1. Part 2, we started seeing, looking at ethics, question about why we should actually study ethics, particularly in the space of social data, because it's extremely important for knowing that we're getting large amount of data doesn't mean that we can actually do anything, and data being publicly available on these platforms doesn't mean that we can actually take it and do anything and everything that we want, right? So that's the important part that we saw in part 2. We'll continue in the same thing. In part 2, we also saw about the whole idea about IRB, Ethics Review Board, importance of IRB, what are the different documents you need to in terms of sending your IRB approval, why, and what are the ways by which you can actually fix the Facebook study or the OkCupid study in terms of some methods that human subjects studies actually suggest, replace, refine, right? All of those methods we saw in part 2. So we're going to continue looking at a similar kind of a topic, bias, in this part. Any questions, as always, feel free to sort of say send it on Discourse. I'm also hoping that in week 10 we've been trying something new, right? The lecture ends, and then we also have students joining in live to the sessions, and they ask questions, and then the question answer is also recorded and then patched with the video. Hopefully that's also helping you to get some answers to the questions that you may have had yourself while looking at the lecture. I think it's very nice to do it. Hopefully it'll help you in clarifying some questions also. Feel free to join the live sessions also on Saturdays to clarify any of your questions. So here is one slide that summarizes probably the entire part that we'll actually look at for this week. So this is, let's go through the figure slightly in detail. And each of the part, we're going to look at it as when we look at the content of this week. So what is affected by biases, the question, how biases manifest, where biases come from. Right? So those are the questions that we can ask. And particularly, we are looking at social data research, social data analysis, because that's what our course is all about. And in the process of last 10 weeks, we've also seen data to collect, what analysis to do, how all you can make inferences, all that. So the type 1 research goals is understand influence phenomena specific to social platforms. Right? Type 2 research goals, understand influence phenomena beyond social platforms. This one is, I study what Facebook users do within Facebook itself. This one is, I study Facebook users, but how they actually do business, how they actually conduct, let's take mass gathering, all of that, which is outside Facebook. How do they actually use Facebook for these kind of activities, right? So broadly, these are two different ways of thinking about, right? Which is one, analyze the platform behavior itself. The other is analyze how the platform is helping behavior outside the platform. It can be both ways again, which is outside behavior showing up in platform behavior showing up in offline, which I think we have discussed in class, or I've mentioned it a couple of times, which is this whole idea called online offline. I've also mentioned that if any of you are interested in studying anything in this topic, I think this is a super critical, super exciting, interesting. Not many people do this, which is study the online and offline behavior for a particular topic. Take a topic, see how online behavior happens. Similar topics, similar users will be even more exciting. Look at the same users, how they behave in the offline world. This will also answer the question of perceptions versus reality. This will also answer the questions of difference between online and offline, right? I mean, you can also think of people showing up on Twitter. There are many people on Twitter who talk about protest, who actually have very, very polarized views. I think when you meet in the real world, or I don't know whether they're actually really protesters who will show up on Jantar Mantar in Delhi and do a protest, right? If you ask all the, so to say, online protesters, armchair protesters, so to say, to show up in the real world to do the protest, I don't know how many of them will actually do it. The same way the other way around, which is on people who are doing actually the protests on the streets, do they actually show up on online, and what the behavior of them are online are. Very, very interesting direction questions to ask. But the goal for our part is the rest of it, which is construct validity. I have individual slides, or more than one slide for each of them, but I'm just introducing the words here. Construct validity, internal validity, external validity. Population biases. So the first one is all about inferences, all about what comes out of analysis that we do. The next one is which is how biases manifest, which is population bias, behavioral bias, sampling bias, right? All this population bias also covers. Content bias, linking biases, temporal biases, and redundancy. That's the, so to say, in terms of data, in terms of analysis. Now, when you look at where biases come from, biases as its source, biases as collecting, processing, analyzing, and evaluating. So you can think of this as collecting tweets, you're pre-processing and making the data available for doing some analysis. Then what analysis you're actually doing on the data, what evaluations are you doing, what metrics are you generating, precision, recall, accuracy, ROC curve, all of that is at this level, right? What metrics you're actually using, are there any biases in the metrics itself? That's what we're going to look at, which is, again, biases at source can be broken down into 4: functional, normative, external, and non-individuals. We'll go through in detail. But the idea is that there are so many biases that you can think of at different levels. When we look at social data, we'll look at each one of them in detail now. Just to compare, or just to give you context, we are using this paper where we'll actually highlight some parts of the paper to show either some of the biases that the paper has, or how the paper actually mitigates the biases. The goal is not just to show that there are biases, right? We should also understand how to mitigate these biases. Again, this paper is only an example. We could have taken any paper. This paper is a very good paper, so we actually picked up this paper to connect with some of the topics that we are going to be talking about. Feel free to read this paper if you're interested in generally social media analysis. This one is particularly about social media analysis and depression. Broadly, Munmun works around social media, and health is a broader area of work. Right? Okay. First part, construct validity, internal validity, external validity. These are the parts that we saw on the top of the figure a couple of slides back, which is where the biases in terms of validity comes in. Validity is also about what is the results that we are getting, right? How valid the results are. So the first one, construct validity. Do our measurements or data measure what we think they measure? Meaning, are the measurements that we're doing, let's take we are measuring accuracy, or let's let's take we're measuring how people are depressed using Twitter or Insta. Using Insta, we are actually studying people who are depressed. Meaning, are we actually, if you collect the tweets, if you collect the posts that they are doing, and seeing whether they're using some words relevant to depression or pictures that they're posting, if you're inferring that they're depressed or not, is that really measuring the depression of the users that we're collecting data? Construct validation is the accumulation of evidence to support the interpretation of what a measure affects, right? Measure effects is again depression, measure effects is like, it's people falling for phishing attacks, all that. Yeah, so this is an example that I took to say about depression. Are tweets actually indicative of depression? Using crowdsourcing, here is what the paper says. Using crowdsourcing techniques, we gather a ground truth set of 69,000 Twitter postings shared by individuals suffering from clinical depression. So here, the argument that the paper is making in terms of saying that the data is valid is that shared by individuals suffering from clinical depressions. There's some way to find out that here is a list of people who are actually suffering from clinical depression. Then I go ask them for their Twitter handle, collect the data that they have posted, and make the inference from that. Right? So there's more validity to this approach instead of just saying that, look, let me collect randomly tweets that people have posted and then talk about how people depressed, how much Twitter users are depressed. Right? That's the construct validity. Internal validity. Does our analysis lead from the measurements to the conclusions of the study? So keep in mind, so construct is about what we are measuring. Internal is about whether what analysis that you're doing is leading to the conclusions that we are looking about. Here is another way to think about it. A piece of evidence that supports a claim about the cause and an effect, right, within the context of a particular study. You really want to make sure that the data that you collected, protesters showing up on social media, there is a protest because of, let's take a CAA, and there are tweets that are showing up. Is there a way by which you can actually bring the link between people who posted the tweet and people who showed up for the protest? Or increase in tweets showed increase in protest, or increase in the volume of the protest, or the intensity of the protest is proportional to the increase in tweets? I think these are all very hard questions, and that's why for us as part of this class, to know all of this after we have done all these topics is also important, because this is critical, because without that we will end up actually concluding a lot of things which may not be actually valid. Is the ML model reliable and accurate, right? That's another way to think about, because you're making the relationship between what analysis you're doing and the conclusion you're making. So we develop statistical methods, an SVM classifier that can predict whether or not a Twitter post in a test set could be depression indicative, right? So they're saying that we have built this model which will actually allow us to understand whether a person is depression indicative or not. Again, like the way that I mentioned about ethics, for us as people working on this data, making all these inferences, I think we should be aware of it, be explicit about saying that these are the problems with the data that we collected, and writing the limitations in the report, cognizant about the fact that these limitations are there in the results, in the data that you collected. And that's what my intent for keeping this content as part of this course is, that given X number of people are getting exposed to this content, I think we all should be aware of explaining the data well, making sure that we are aware of these problems with the data that we collect in large scale from social. This is another interesting validity. Again, let's go back. Construct internal within the study, now it's external, outside the study. What results that we are getting, how generalizable it is. To what extent can research findings be generalized to other situations, right? Let's take the protest example itself. We see that there's a relationship between number of posts and people who posted to the protest for CAA. Is there a same kind of protest for, let's take farmer protest, right? Can we generalize the results that we get in one domain to another domain? Can we generalize people using Windows falling for phishing attacks? We studied everything for users who use external validity. External validity now is looking at what results that we get is how does it connect to the other situations that you can study. We study in one context. Is it generalizable to another context? Is the external validity. To what extent can research findings be generalized to other situations? Let's take, we do the analysis of CAA protest, saying that there is relationship to tweets, to actual protests. If I replace this CAA with, let's take, farmer protest data, is the results generalizable? You remember in the part 2, I actually talked about statistically significant difference. That's where it comes in handy when you want to actually prove that whatever you've done in one context, if it is statistically significantly different, which is, or similar in that sense, say different meaning people behave, there's a statistically significant relationship between the tweets that are posted and the actual protest, number of people showing up, or number of number of likes that people get on the post, all of that. You show some relationship between these two. And if that relationship can be reproduced in other scenario, then it's actually generalizable. Externally valid, you can say, if you want to say it that way. It is the extent to which the results of a study can be generalized to and across another situation, people, stimuli, and times. For example, we study all the people using Windows for their vulnerability to phishing. And now we want to actually understand whether Mac users are very similar. Will the result be valid in another scenario, another context, is the question. Are the analysis of ML models generalizable to other population, which is they collected data in the, let's take in one context, is it applicable to another context, right? I think this one should be, yeah, this one is probably wrong here. The image should be talking about data from the US, right? The study Munmun collected data in the US. Can we actually think of using that data, and can it be actually applicable in another situation like India? Right? So this is also should have been US to India. Okay, so that's what external validity is. They studied in US, is the results generalizable to the US India data? Okay, that's about construct, internal, and external validity. Let's move on. Bias in social, continuing with the bias, and we're just continuing in the same figure. Now we have gotten the second part of the figure that I showed you earlier, which is how bias is manifest. Population bias, behavioral bias, content production bias, linking bias, temporal bias, and redundancy. We'll see one by one. Population bias. Distortion in demographics between users in a data set under target population. Right? It could be the way, right? If the data is collected from the US, but we want to study Indian population. This is the reverse of the what I said earlier, which is in terms of validity. Will the study be valid in the US? Will the study be valid, data collected in the US? Will the study be valid in India? Is the external validity question, generalizable question. Now the bias question is that if the data is collected from the US, but we want to actually study Indian population, then probably there's a bias there, right? So we sought responses from crowd workers who were located in the US and had an approval rating of greater than or equal to 90%. That's the part I said. They did the data collection from the US. That's the population bias, right? The data, the users from where we are collecting the data. Behavioral bias is the distortion in user behavior across platform, context, or data sets. If users are more expressive about their depression on Reddit versus Twitter, the reason being this is, let's take pseudonymous and this is identifiable, is that the reason why people are posting different type of content in these two different platforms? Right? That's the behavioral bias, right? When I go to Twitter, when I go to Facebook, probably this is there naturally also in some of these platforms, right? When I go to Twitter, I know that when I post it, it's really, really public. When I go to Facebook, I know that I can actually control it only to my friends, and possibly I kind of control the post or control the content that I actually want to generate on Facebook. That's the bias. I could have that bias inherently. I think please keep this thread across all the slides. What we are talking about is inherently these biases are there in many of the questions that we end up asking, methods that we end up using as part of social data research. Here is an example, right? Buying an old car, then spending more money on repair, more than the cost of the original car, just to avoid the question about, or just to avoid the embarrassment about, oh, I made a mistake by buying an old car, right? That's the behavioral bias that I have, right? I bought a car and I'm spending more and more money on just fixing problems with the old car instead of actually buying a new car. It's a behavioral bias, right? You can also connect to this if you really make the connection. You can think about bounded rationality that we talked about also, right? So where users make choices within a particular set of choices only that they have. There could be a bias in the choices that I make itself, right? Okay. Content production bias, right? Now, it's not about users. Now it's about the way that we generate the content from, let's take these tweets. Differences in semantics, syntactic, and structural content generated by users. Users on LinkedIn produce formal content as compared to users on Twitter, as compared to users on Instagram, right? So when I look at the post on Insta, it's just like few words. That's all they express, right? Many a times. On the contrary, some people express it in like 20 different hashtags. It's only hashtags and Insta posts for some people, right? So the way, I don't know whether anybody would create such a post on LinkedIn. So therefore, there is a bias in the way that the content is getting produced in these platforms also. Differences in usages of language across different gender and age group. The so to say, lingo that I would use on my post versus the lingo that you would use, or assuming that many of you are younger people, younger audience for this course, when you do your Insta posts, probably the emojis that you use, the text that you use are very different from my post. So that's the product at the production level itself. One, the platform is having a bias the way that I create content. Two, as users, we also generate actually different types of contents in these platforms. Linking bias, right? So this is social network constructed from online patterns, may be different from offline patterns. So in some users, the network that they have on online platforms like all of these Facebooks, Twitter, may be very different from what the offline connections that they have. I mean, I know some people who have actually very distinct difference between what an online connection is, what an offline connection is, and distinct difference in the way the people that they actually connect on these platforms also. They don't connect with some, so to say, family members, some close relatives on any of the social platforms, right? So those are the kinds of behavior that people have, because of which the bias may be generated in these platforms. Followers and friends of a user on Twitter may be different from their offline friends network, thus biasing the analysis. So therefore, when we collect the data from Twitter and say that here are the sets of followers that this user has, and even if you take the bidirectional network, all the bidirectional network that we take, which is people whom this user follows and all the people who follow this user, still I don't know whether we can actually establish that any friendship relationship, any strong relationship between the users because of this bias. We define two features that characterize a post author's egocentric social network: the number of followers or inlinks and the count of her followees or outlinks, which is what I mentioned. So this is an inlink in degree. This is a outlink or an out degree. That linking bias itself may be the reason the conclusions that we draw, or we should be aware that the conclusions that we draw may not be correct, may not be related to the user's real world presence. Right? Temporal bias, here is another one. Depending on the time of the day, my behavior can be very different on these platforms, right? Difference in user population behaviors over a period of time. So if you look at this graph, this is also a graph from the paper itself. This is diurnal patterns, which is a pattern for the day, which is 24-hour clock is on the x-axis. Y-axis is index that they have created for depression. And the pink color is women, and gray color is men. And you see that there is men here, there is women points here, and there is a regression line connecting all these points. That's what this women and polynomial regression line, which fits the women data and the men data. That's about the graph, right? But the problem is there's a difference in behavior of men and women on Twitter throughout the day. If you look at the data, there's this difference just because of it may be because of the gender. That's also something we should actually be careful concluding. It may be because of the gender. That's the point that we have to keep in mind for the temporal. This also connects with the sort of behavioral, right? Just being a male or a female may have this behavioral difference on these platforms. This is time, and there is also interesting things that maximum, if you see, right, is at the 24 hours. So this is more at the midnight time, and this is during the lunchtime, during the half day time of the day. Right? Interesting patterns, and knowing these patterns also helps because you can actually devise different solutions keeping these patterns in mind. The last one is redundancy, which is identical or near identical data items that appear in the data set multiple times. One of the problems with actually the social data is this redundancy, because it's huge amount of retweets. Let's take if you collect a tweet posted by a popular user, and you do the data collection and you collect all the RTs of the tweet, right? There's going to be, let's take 20K, not 20K, let's take 200 times RTs done. Those 200 tweets are nothing, right? It's just you know that it's 200 times retweeted, but the content is going to be exactly the same unless it's actually a quote, which probably has some more text added to the RT that the user does. Retweets might contribute to redundant, repeated content in the analysis. So you want to always keep in mind about the retweets. Similar things that are in other contexts also, you want to keep in mind of the redundant data that we end up collecting. Okay. So that is the second tier. The next tier is bias at the data source itself. Right? So this is functional bias, normative bias, external bias, and non-individual bias. Let me go to the figure again, just to tell you where we are right now. Right? So we did this, construct validity, internal validity, external validity. Then we did population bias, behavioral bias, content, linking, temporal, and redundancy. Right, so this bias is done. Now let's look at the biases here, which is at the where biases come from, how the bias is at the source itself. Okay. Functional bias. Due to platform-specific mechanisms and designs, right? So you can think of LinkedIn having a repost, like, comment versus Facebook's share, like, Twitter's like, retweet, quote. There's all these different mechanisms by which you can actually create content on these platforms. Insta having more of, so to say, these reels and more of stories, right? So the way that the data is getting generated itself, due to platform-specific design and mechanism, the bias may exist. For example, on Twitter, found that introduction of emojis lead to decrease in use of emoticons. I know if you know the difference between what emoji is and emoticon. Emoji is more like a image for expressing an expression in that sense, or whatever you want to convey. Emoticons are the ones that you can actually produce using the keyboard with some keys. For example, the smiley M, right? This one, let's take this one, all of this is part of emoticon. Whereas if you have a, sort of say, a person running image or something like that, or a tree or a plant or a flower, right? All of that may or may not be keyboard reproducible, right? So they did an interesting study to show that introduction of emojis led to decrease in usage of emoticons. Now that I have all these fancy images, people started using the emoticons more lesser, right? So which is, again, a functional bias, right? Where the platforms, meaning I'm sure if some of you have used all these platforms for longer, LinkedIn, Facebook initially had only one like button, and then they went on to do 6 different emojis or emoticons that you can actually produce. And there are even multiple papers to show how Facebook actually did the research to decide on what these emojis should be. So therefore, the design of these platforms itself can generate a bias in which the data is getting generated. Yeah, so that's the paper. That's the paper which talks about emoticons versus emoji on Twitter, a causal inference approach, which this is what I said before. Emoji is pictures, emoticons are using keyboards. Okay. Normative bias is due to written or unwritten rules and expectations of acceptable behavior on different platforms, right? Normative, right? Expected behavior. It's been observed that the users who disclose their real name are less likely to post about sensitive topics compared to the users who use pseudonymous. This may be the case that we saw earlier also, which is Reddit versus Twitter. Pseudonymous versus possibly real name. Probably a better example could be Facebook itself or LinkedIn also. Reddit versus LinkedIn. Right? So in pseudonymous, you're more likely to probably share about your depression. You're more likely to share about your polarized view on the society compared to a LinkedIn. The tendency is to assume that anything goes against an established norm is not effective or appropriate. That's the definition of what normative is. that is a non-traditional career path, someone who dresses differently, etc. That's the normative bias. External bias. Again, remember external validity we saw, which is generalizability. Now we are looking at external bias. Due to factors outside the social platform like socioeconomic status, religious, political leaning, education, culture, geography, state, GDP, Democrat, Republican may be important external factors that define how they actually use the platform. Right? So in this case, it says the statistics of 20 US cities with high depression rate. So they calculated this depression index, and then they went and looked at cities which had the higher depression index versus low. So therefore, meaning there is also the demographic details which is actually also influencing the depression rate, right? It could be that somebody living in New York is more or less depressed compared to somebody living in, let's take Pittsburgh, right? So in the US data, in India, we could think of Indore versus, let's take Hyderabad versus Bombay versus Chennai. There could be depression index may be very different in these cities. Non-individual agents, which is interactions produced by organizations or bots. This is probably a huge problem in all of these platforms. You collect data for Twitter. You collected 30,000 posts. You don't know how much of this is posted by a bot, right? Or a targeted or a organized set of posts that has come from organizations. Some tweets behavior may have been done by automated Twitter bots. Bias at the data collection, right? So now we are looking at, so until now we looked at some platform problems. Now let's look at when we collect, meaning when as part of this course we have also collected data, right? If you think about the data that we have collected, there are going to be some biases. We'll see what some of the biases are. Data acquisition bias itself, which is platform may not give access to all data that they capture. We saw Twitter giving only 1%, right? API sampling strategies. So we will actually look at some, meaning last part or last week I mentioned about some study done on Twitter to find out ways by which the Twitter is actually sampling. We'll actually look at that study detail today in this part. API sampling strategies, right? Are they giving you every second, every minute, every hour, meaning 0000 time? How are they doing the sampling when you are asking Twitter for 1% of data? That sampling strategy itself may be actually a bias in the conclusions that we derive. Data querying, you collected data for protest, hashtag protest. Somebody collected the same thing with riot, meaning just because of the change in words, the data collection may be different. Meaning I'm giving you an example of one hashtag each, but just think about 15 different hashtags for collecting data by researcher A and another 15 hashtags. The overlap is only, let's take 10. There are 5 different hashtags which both of the researchers use differently. Now that's going to be biasing the data conclusions that we make, right? That's the data querying bias. Location-based data might not be reliable, right? You get 1% of this geotag post. Is that really the location that the person was? We can argue. We can also look at, if you remember in the past I've said about my own post, which is hello, a city name, maybe that I'm not even in that city, right? Or traffic in this location. I was there 1 hour before. I took the picture and then I posted it like 3 hours afterwards, which means that I'm not if you're making conclusions of real time that if I'm part of that traffic jam right now, then that's probably wrong. Data filtering. Outliers are sometimes relevant for data analysis. Generally, we end up removing outliers. Sometimes it may be the case that outliers are necessary. Stop words and functional words may embed signals about authorship, emotional dictates, etc. I think generally also we end up removing the stop words. When we do the NLP, when we do the pipeline, you take the tweet, you run it through first to stop words, then probably do EDA, from which you will actually remove the outliers. These are general sort of a pipeline that we use for data analysis, but it may be the case that these stop words, these outliers are actually necessary for the study. Now, bias is due to data processing. The last one was data collection, data acquisition. Now the problems with data processing itself. Data cleaning, right? Look at these examples. Normalizing text may change semantics of user data. Running shoes. Let's take if you were to do the stemming for this running shoes tweet, and then it turns out to run shoes, the whole meaning is gone, right? Second example is I was born in NYC. If you do the lowercase for all the text, it converts into I was born. So this NYC's become small case NYC, and the inference may be very different because small case NYC may be interpreted as nice in this case, right? So keep in mind all this data cleaning. All of us do this cleaning. All of us do this processing of data while doing the pipeline. We just have to keep in mind some of these things. Default values for missing data might skew results, right? So if you end up deciding that, look, there are some, because of some glitch, I did not get the data, or I got only the some parts of the data, not all, I will just replace it with the default data that I got for some users. For all users, that may be very wrong in terms of decision making. Right? If you're missing data, do not replace it with default values. Data annotations. This is something that many of the projects that we end up doing on social will need annotations, particularly this actionable, particularly the societal and facing problems. So the annotations are also very, very biased, right? It depends on who's annotating it. It depends on, so that's what it's unreliable annotators. Poor annotation guidelines. Let's take that if you are not clear of what you want and if you did not explain it very well, it may be a problem. Low annotator agreement, which is you asked 3 people to annotate, take an image and tell me whether there is this is phishing or not, this is fake or not. One person said yes and 2% did not say, 2% said that it's no. And you collect data like this more, there's a way to find out how the inter-annotator agreement is, whether the data is very strength. It's called Cronbach's alpha. There are many words for this. So one of it is Cronbach's, Cronbach's, Cronbach's alpha, which measures how when n number of people are asked the question about something, how much agreement do they have, right? So if this agreement is very low, which means that people are not agreeing to the question that we are asking to them and agreeing to the problem that we want to study, then it will be very hard, right? It will be very hard to justify the data that you collect if the agreement is actually very low. Bias due to data analysis and evaluation. So now where we are with this one is data processing. Now we are going to look at analysis and evaluation. Descriptive statistics. Correlational analysis are sensitive to confounders. So confounders are a huge topic, meaning any of you interested in taking up any of data sciences things, probably as part of your degree program itself, you should study confounders more, because there's a huge amount of confounders in many of the analysis that we do. Confounders are, you make a conclusion that male are different from female. Let's take in terms of identifying fake news, identifying phishing emails, right? But it may not be that the male and female is actually the reason for the difference. It may be all the male that you studied and all the female that you studied have geographic locations which are very different, or their economic status is very different, right? So in that case, it's not the gender. Gender became a proxy or a confounder in that sense. There may be other confounders in the data that you actually look at. Inferences and predictions, train and data samples impact results. Amount of trained data, amount of test data, what type of trained data, what type of test data, all that. Metric selection. Choice of metric shapes the results of the research study. I mean, there in statistics class, if I were to teach, I would say that using statistics, you can prove a lot of things, lot of opposite things with the same data also. There are even research papers written taking the same data, somebody proved A, and then somebody proved A prime, which is opposite to what A was. Right? It's the way how statistics can be actually used to defend what results you get. Right? Choice of metrics, you define precision, recall, all these metrics that one can use. You can use it to your advantage to say what results you want to talk about. Okay, so that's where the bias figure that I started ends, which is different types of biases, bias at the platform, bias at the data collection, bias at the analysis, validity of the results that we get. All of that is what we saw until now. Let me take a example. This example I've referred once earlier in this lecture. Also, I mentioned about this sampling bias that they were studying. Fantastic paper. If you're interested, go take a look at this paper. This paper talks about, so their interest was to study how Twitter is actually sampling when through the API. When we ask for data, how are they deciding to give us the data, what data they are giving. Bias is built into platforms, but rarely corrected or acknowledged. These are the ways that the authors were expressing what they were thinking. Getting data from Twitter, when do we get what, right? So can we actually identify how Twitter is actually sampling and giving us the data? So these are two different ways by which you can actually collect data from Twitter. Streaming API and Firehouse, you know about it. Let me talk about more the interesting part of the bias itself. We get 1%, that also we are aware. Coverage changes dramatically because of the way that this 1% is picked. Providers don't tell you how. Unfortunately, Twitter doesn't tell us how they are actually deciding to decide how they are picking the tweet to give it to us when we search for hashtag protest, right? Algorithms drive data and behavior. You think about it, right? I'm sure many of you are watching YouTube, binge watching on Netflix, binge watching on YouTube, right? The algorithms that YouTube is producing is defining the way how we actually consume content. Social forces, homophily and transitivity. Homophily is connected to echo chamber that I mentioned before, which is birds with same feather flock together. I like cricket, I can connect it to people who like cricket. Right? Transitivity means the clustering coefficient, right, of the network, clustering coefficient of a social network graph, right, is strong. Right? So when the clustering coefficient is high, the network is very dense, and therefore the information flow can be very, very to the group that information is sent to. Right? Homophily and transitivity. These are could be the reasons the bias is percolated because the way that the network structure is. Social media systems intensify these effects with link suggestions. The recommendations that these social platforms produce is built on these ideas of homophily. Interaction between human behavior and online platform design. So the users, the way we use these platforms, how we use this platform is actually deciding the way that these recommendations are made. Do we analyze society? So the critical question is this, right? If you collect the data for, let's take traffic police of some city, and we are analyzing, what is that we're analyzing? Are we analyzing the user behavior of the citizens of that city? Or are we analyzing how the platform is designed to actually showcase this data on this platform? Super fundamental question to ask when you're analyzing the social data. This also, I just put it here just to recollect 3 different ways of collecting data: REST API, streaming API, and sampling API, based on which method you use to collect data. Right? Here's a paper, and paper 2 graphs that I will show you, 2 slides or 3 slides. I'll show you what the paper ended up concluding. Which is sample of all tweets, sampling based in milliseconds. So Twitter ended up designing the sampling method at a millisecond level. Okay. So 6th hour, minute, second, millisecond level is what they decide whether to give this tweet to you when you sample for data. Consider a Twitter bot. What they ended up doing was that now that they have understood that it's at the millisecond level, they started playing around with it. Consider a Twitter bot, which is tweeting weather in Hyderabad exactly every 5 minutes, 10,000 times, right? 10,000 tweets it posted. How many tweets will be in the 1% sample, right? If I have done every 5-minute a tweet 10,000 times, is there a chance of having the tweet? If so, how much of tweets will be in this 1% sample? If you do the math, I'll stop the video, think about it, do some math and see what the answer is. But the answer is that most likely nothing, right? Given that they are picking it in a millisecond, if you just do it every 5 minutes, 10,000 tweets, because if it's just not matching at that millisecond point, Twitter is not going to give you the data at all, right? So therefore, this is an example of bias originating from a platform, because given that it is not, if ideally one way to think about it is that Twitter could actually think about it as completely random, right? In a random way of a given second, given millisecond, whatever, pick the tweet and give it. But they have done it in a constant millisecond, and therefore this method of no tweets can show up if you're posting it exactly every 5th minute. If you post, there's a high probability that none of it will come, because if that 5th minute that you're posting is not aligned with the Twitter's millisecond time, the tweet is not coming. Here's what they did. They posted some tweets. This is during 2016 elections, I think. The data that so x-axis is date and time of the tweet during November 2010. November 2016, right? I thought so. So this is original tweets. This is normal tweets. Our tweets, normal tweets, and 1% API. So essentially, they compared their data with 1% tweet. They figured out that they were able to send 1,000+ tweets and get all the 80% of the 1,000+ tweets that they posted into the 1% sample that Twitter was giving back. Okay. So if you think about it, if they could have done this for the entire, instead of just 1,000 tweets, if they would have done like 1 million tweets or 1 billion tweets, in the 2016 November data, whoever collected the data, whatever research was done, it could be all biased, right? Because these people injected the tweets to show up in the sample output. That's a huge bias in terms of the way that the sampling is done. That's what this paper showed, which is that they could actually inject, figuring out the sampling method on Twitter, they could inject tweets, 80% of their tweets got into the 1% sampling. The reason why this is interesting is because if you do this, you're getting only 0 posts, right? Broadly, to keep in mind, social media research, given that we have seen a lot of this data collection analysis as part of this course, the systems are closed, data is mostly hidden because it is going to be hard to know what data you're getting actually. Unknown algorithms, I just now showed, at least from the Twitter, but many of the YouTube, Google, all of this, the algorithms broadly one can get a sense, the number of times website is linked to other websites, and the popularity of the websites is defined the way that the website is shown in the Google output, page rank idea. But that's really, really at a high level. At a minute details, there are lots of details in the way that the Google is producing the results. Systems may not be perfect, which I think is very fair and understandable also. We don't really know what we get sometimes, because it's not clear what data we are getting is what we wanted for. Could be manipulated. Like, for example, the researchers I just now showed, the data may be manipulated, the data may be bots. Because of all that reasons, you want to make sure, you want to keep in mind that the data that you're collecting may be manipulated. So what do we do, right? All these bias are there, all these problems are there with data. Should we just say that, look, forget, I'm not working on social data. Let me just forget about this course. After I'm done with this course, I'm just not going to touch any social data, and then move on to some other part of computer science work or a data science work. And probably data science work is going to be hard, but even in data science work, right, you can move away from social data and do a lot of other things. But I don't know whether that's the way to think about it, right? I think these are problems there, but the most exciting problems are also in the social data. So there's a huge list of suggestions, proposals that people have come up with. ACL, Association for Computational Linguistics, as a sort of say, has come up with a list of NLP, for NLP research from social data, for NLP research. They've created this list of things that authors should look for. But the broader goal is authors should know about informed consent, IRB, ethical review, reliability, and validity. I think as part of this course, we have covered everything: informed consent, IRB, ethical review, reliability, and validity. Let me just quickly show you what that document is. If you go to this URL, it actually gives you it's probably a 6-7 pages long document, giving you a list. I just produced only a few here just to give you the sense of what the list is all about. Did you describe the limitations of your work? This is for the authors, right? So the context is that if you're submitting a paper in ACL, they are saying that authors should go through this list and answer these questions, so which can help the reviewers understand what the authors did. Did you describe the limitations of your work? Did you discuss any potential risks of your work? Did you cite the creators of artifacts you used? Did you discuss the license or terms for use and or distribution of any artifact? You picked an image from somewhere. Did you cite it properly? Did you give the license credit to them? Did you report the number of parameters in the models used, the total computational budget and computational infrastructure? Did you discuss the experimental setup, including hyperparameter search and best found hyperparameter values? Did you report the full text of instructions given to the participants, including example screenshot, disclaimers, consent form, annotators, etc., etc.? Right? I put this ... because there are many more in each of these categories. There are 4 categories, A, B, C, D, and each category had like few of them. I just picked a top few just to walk through, to give you a sense of what as researchers, what as data analysts, data scientists, when we collect data, we should actually keep in mind. I think as the last part ended in terms of ethics, this very similar slide here, which is we should be aware of the biases that might creep in. We should acknowledge that the bias is there. We should acknowledge that the ethics issues are there. Meaning explicitly state it, right? everybody understands this, meaning the reviewers also understand that the social data has all these problems. People reading about the report also understand it. Be transparent, mention limitations in papers and reports. Make sure that you say that, look, we collected protest data, we collected only 1% of the data. There may be lots of other data which we are not capturing. But the conclusion that we have gotten is using statistics, you argue that there's a lot of internal validity in the data that we have collected. There's construct validity that we show, and potentially there's also external validity, which is the hardest part because that's actually talking about external generalizability of the data. External validity, if not external validity, at least the construct validity and internal validity you should actually talk about. Okay. So that's what I had for this part. We will stop here and look forward to having you in the next week. But to summarize, what did we see? We in this week, we started looking at some studies where some ethical questions were asked. From there, we went to ethics of studies. Then we understood how these studies can be a little bit fixed. Then IRB. Then this part we did bias, in bias, large list of different biases, and some validity, how to do the studies a little better. Okay. With this, I'll stop. Thank you for listening to the lecture.
Sir, so I have a question. I have this. I have downloaded this data for Nagpur police tweets. And I want to check their response times on like their average response time, maximum response time, minimum response time, as mentioned in previous lectures. But now I have this problem. I want to consider only those tweets or replies where they replied to a tweet which was actually asking for help. I don't want them. Don't want to consider a tweet where they replied to something saying thank you or something to a normal tweet. So how do I, like, is there any automated system or is there a library which I can use to check if a tweet is asking for help, or do I do it manually?
Yeah. So interesting question, right? And it's also good to know that you're collecting data and doing all this analysis yourself. I think to start with, you have to look for only those kind of words. If you remember in the lecture, we saw some trees, right? ABC want to get data. ABC needs help from this mind tree, they are called, right? This kind of words you'll have to look at and probably do some regular expressions on or look for these words on the unigram or bigram in the text that you have. Mark them, look at manually, annotate them on whether it is actually asking for some information. Learn from that and use it to so to say annotate annotate other tweets that you have. I don't think so there's any such a plug and play tool which would allow you to say that, oh, give me all the actionable information from this tweet and you will get the actionable information. Or at least in your case, give me all the tweets of this 1,000 tweets that I have, which are the ones which are asking for information or needing some information, and then give it that. I don't think so that's going to be easily possible by just a plug and play tool.
Okay, sir. So yeah. It's better if I just, for example, take the word help or something and ask, run it through this unigram or bigram of the tweet that I create.
Tweet that you have, yes.
Okay.
And tag those tweets first, and then look at them manually, saying that whether they're actually, meaning it could be a sentence could be framed with the need or want without asking for any information, right? It could be some other context, so you want to remove them also.
Okay, sir. Thank you. So I have a few more questions from the lecture today. So I just wanted to clarify when you talked about internal validity when we do research. So basically, does internal validity indicate to the point that whatever method I am using, is it correct? Like if I say, are my methods correct? Am I checking internal validity of my research?
Yes. So internal validity Basically, the text in the slides are, does our analysis lead from the measurements to conclusions of the study? A piece of evidence supports a claim about the cause and effect within the context of a particular study. So you're looking for the correlation, the cause, the reason, the symptom, all of that within your study. I collected information about people falling for phishing attack. I collected information about people consuming the fake content, and I used a particular sort of say method to understand how they perceive a phishing email. I collected that information. Only within the study is my sort of say metric, is my way of analysis is appropriate.
Understood. Uh, and the second question came to me. It is regarding functional bias on social media. Uh, I have the question with me. So I this is an example. So as you already mentioned, Facebook did a research to capture these six emojis and say like these are the ones that should be used on every post so that it covers most human emotions, for example, while reacting to a post.
Yeah.
So when, for example, LinkedIn last year introduced this funny react button last year, I guess. So does that, for example, do these sort of things contribute to functional bias? For example, if I'm
Yeah,
collecting data on LinkedIn.
yeah, absolutely right, Kunal. The reason why this is functional bias is, for example, I have collected data before the change that you said in LinkedIn, and after the change happened in LinkedIn. Before Facebook changed the emojis, and after Facebook had done the changes in the emojis. So, which means that the results that I derive from the data that I collected before Facebook made this change of six emoji versus only one like button is very different, right? Meaning people did not have a way to express anger in a post. So I could not have measured anger at all. So that's the functional bias that the system has.
Understood, sir. Uh, another another question is one where, like in the first diagram, I guess the very first diagram that you show for the whole crux of the lecture, at one place it is mentioned about cleaning the processing phase in the last stage. Says three things. One is cleaning data, enriching, and aggregating. Sir,
Yeah.
can you just please tell what does enriching would mean? What would mean by enriching data?
Sure. So let's go to the processing slide. So data collection, data processing, right? So data processing, we have data cleaning, data annotation, all that. In the figure for data processing was cleaning, enriching, and aggregating, right? So cleaning, I think we saw. Cleaning is more of the stop words removal, more of the stemming, all of this. Aggregating and enriching, right? There are, meaning, there are methods. I collect data, let's take 100 rows. There are ways to understand that, okay, what does this 100 rows look like? And can I add 100 more? I understand the model, I understand the pattern of X amount of data that I collected. I synthetically generate more data to add to my data set. For example, more recently we did um, social media and code mixing data. So code mixing is this usage of two languages in a sentence, right? मैं अभी lecture record कर रहा हूँ. Can I meet you tomorrow at 4 o'clock? I just used Hindi and English together. This is called code mixing, right? In this code mixing, some work that we are trying to do is to, can we actually build a pipeline to say that input is the code mix tweet, output is the sort of sentiment, whatever you want to analyze. Today, we don't have that pipeline. Today, we don't have this infrastructure to do the code mixed content. It can do Hindi, it can do English, it can do probably other few Indian languages, but not the code mix. So while doing this, we wanted to create data set for this is a paper that recently we have, which is we wanted to create code mix data to do understand to build this pipeline. But code mix data set doesn't exist. We went to Twitter, we started collecting data, but annotating them is expensive. Annotating them and understanding code mix data from Twitter is also very noisy. We wanted only 2 languages, but some tweets are having 3 languages, all of that. So what we did said was, look, let's create a synthetic code mix data for doing the analysis. We understood some patterns of the code mix data, and using those, let's take there is Hindi and English. Most of the times, verbs get switched. When I say I switch the verb only to, let's take English to Hindi and make the sentence, or a noun or a adjective, whatever that is. Now, using that, can you actually create synthetically code mix data and do the analysis? That's what we ended up doing, which is what here, which means enriching. I'm enriching the given data for with more samples. When I do that, is there a possibility of bias that I'm generating? Okay. Aggregating is, yeah, go ahead.
Okay, so like even like if I am creating additional data from whatever I have to make my sample bigger or whatever, more representative of what I want, at that point this particular thing of just a moment, this
Enriching.
particular thing of yes, bias from enriching comes in at this point whenever I'm enriching the data or adding data points, for example.
Yeah.
So bias might creep into my data.
Correct. And then the next aggregating is that sometimes you want to do the opposite, right? You got a lot of data and you are saying that, look, let me put all the male data that I collected together, or people data that I collected. Aggregating is that, right? I don't want every single row. I want to just put all of them together. Not all of them, but some parts of it. Let's take people all from Chennai, I put them together and represent them in one row of this. In that process, you will also generate bias because what you ended up doing is that let's take from Chennai, there are 40 people whose data points were there. You averaged it out, or you took a median of all the columns and you put that as one row. Then you actually injected bias into the data.
Okay, so when we are compressing data, for example, like just trying to make 40 rows or 20 rows into one row, trying to represent all people in Chennai by just one person, it will create some bias.
Yeah.
Okay. Got it, sir. And just one last thing, maybe the answer would better be explained like if I read the research paper, but it is just an extension of what this research paper said in this particular slide of the Twitter one where they tampered with the Twitter sample API. So yeah. I just wanted to ask when Twitter does this. This is very specific to the structure of code I think that Twitter has. But when Twitter creates such an API where they are just giving us the tweets for a certain span of milliseconds when I use the sample API. So is that sort of design intentional, or is it some poor design from a programming perspective, or is it that?
No, I think it is okay, right? They thought that every so to say millisecond of a second, or every millisecond of a minute, if I sample it, it is probably, so to say, random sample. It's not random, but still it is enoughly 1% of the data that I can actually give some people. I don't think so. It is a poor choice. I mean, it looks poor now, but for a decade or more, people use that and made all the conclusions that we have done with the Twitter data. Right? It is one model that they picked. Even now, I think the paper now, which meaning when they changed the model to something else other than this millisecond and some randomness that they have added. Even now, I think Jurgen, who's the professor involved in this paper, is trying to show that I think he has a recent paper which is still in production to show that even the current model can have some bias in it.
Okay, sir.
So
That
yeah, you should
was
look
all.
at Jürgen's. You should look at Jürgen's recent papers that he has done.
Okay,
Okay,
okay. So
cool.
I guess
Yeah,
this just points to the fact that even at the millisecond level, Twitter, you cannot make an assumption that all tweets will happen as a uniform distribution. They,
yeah,
even at the millisecond level, there is so much randomness inside of, I guess, social media. That is
yeah,
why this particular phenomena popped up. Thank you,
yeah,
sir.
yeah. Yep.
That was
Okay.
all. That was all the questions.
OKR. Good. Thanks.